This module will extend the work that you've already done trying to find the area under a curve. Let's have a look. Here we have a non-negative function, and we wish to find the area underneath this curve, bounded by the x-axis, between an x value of a and an x value of b. So we're looking for the area under this curve, bounded by the x-axis, between a and b. So we're looking for this area right here. Well, we have studied in this course that we can represent this area with the definite integral from a to b of f of x dx. Now this should be familiar to you. If it's not, you need to go back and review that portion of your textbook. So suppose I have another function, y equals g of x. Now notice, y equals f of x is greater than y equals g of x on the interval from a to b. Now our goal throughout this module is to compute the area bounded between the two functions. Now you can probably figure out how we are going to do this if we were to take the area under the curve of y equals f of x. So we'll take all of this area and then subtract the area under the curve of y equals g of x. We will be left with the area bounded between the two curves. In other words, the area bounded by these two curves, okay, the area between the two curves between a and b, is going to be the integral from a to b of f of x dx. Again, that's the area, the total area under the curve of y equals f of x. Then we will subtract the area under the curve of g of x, or we write that as the integral from a to b of g of x dx. Using some integral properties, we can combine and rewrite as one integral. That is the integral from a to b of f of x minus g of x dx. Now, as you go through this module, it's important to know which function goes first. In this case, the greater, or the larger of the two functions on the interval is listed first. The examples, self-evaluation, and worksheet problems will lead us through the use of this formula. These problems will also show us several variations of how to compute the area between two functions.